Alright, in section 1 to 4 we have discovered how to carry out sampling so that we can get a pool of data that is representative of the larger population. Now that we have the data from the sample, what are we going to do with them? So chapter 25 section 5 onwards we look into this aspect. Whatever we are doing now will have a huge bearing on the next chapter, that is chapter 26 on hypothesis testing. You will also have a sense now how powerful and appropriate the normal distribution is. Now let us recap back the essence of sampling. Now in sampling, which is always the case, we have a certain population where we are very interested to find out the characteristics of this population. Right. So the characteristics of the population are usually the measures of the central tendencies. In order for us to look into the characteristics of the population, we look into the two parameters that describe these characteristics, and these are the population mean and the population variance. The population mean is usually signified by the Greek letter mu, and the population variance signified by the Greek letter sigma squared. And of course, sigma is the population standard deviation. Now it is very important that from now on, whenever we say mu, you must always think about mean. But what kind of mean? It must always be population mean. And when we talk about sigma squared, you are always thinking about variance. But what kind of variance? Population variance. Right. So as you can see in this figure here, the population, the parameters that describe this population are the population mean mu and the population variance sigma squared. And as I have said, the population is usually something which is very large, and it is usually not very practical to look into every single data of the population to find out what are the values of these parameters. So what can we do from here? So what we can do is actually to get a sample from the population which is representative of this larger population. So from this figure, what I can do is I can get a small sample like so. Alright, and using the data found from this smaller sample, for example, the two characteristics of this small sample will be what we call the sample statistic, and there are two. We always look at the sample mean, signified by usually x bar, and sample variance. Right. Now from this smaller sample of the larger population, using the sample mean and using the sample variance, we could actually under certain processes estimate the population parameters, namely the population mean mu and the population variance sigma squared, right, which we're going to develop later in the later part of this chapter. Right. So currently we are only looking at how to actually calculate the sample mean and the sample variance. We will talk about the significance of the sample mean and the sample variance in a short while. Now in order for us to actually have a good representation of the population, it is therefore very important that you actually come up with a good sample, and that was what we covered in section 1 to section 4. Alright, how do we then calculate the sample statistics, sample mean represented by x bar? Basically what you need to do is collect every single entity within the sample. Alright, so let's say you take a random sample of size n. So in this particular sample there are n items. Alright, so in order for you to actually get the mean, as you already know, you get the average value. Alright, so therefore you actually have this formula here. Right. Now for the sample variance, it is a little bit more complicated, but not very difficult to understand. As you all know, standard deviation refers to the dispersion of the data, alright, around the mean. Okay, so as you can see from the formula that I present to you in here, alright, the variance is given by the summation of the difference of every single value from the mean and squared. Alright, and this is divided by the sample size n. and this shouldn't be very difficult to understand, as we already know when we talk about variance, we talk about the dispersion of the data from the sample mean. Now we shall look at the first example on how to actually calculate these values. Alright, let's look at example 7. Now in example 7, you're given sample size of 5. Alright, so you will know that you need to have 5 data points. Alright, in this case x1 equals to 2 and so on until x5 equals to 5. You are asked to find the sample mean and the sample variance. Alright, so basically, like what I've just explained in how to find the sample mean, you get every single data point and then divide by the total number within the sample. In this case is 5. Alright, so you have 3. Alright, so for the sample variance, similarly like what I've explained, alright, using this particular formula, alright, you will be able to get the sample variance. Now, does it mean that you always need to use this formula to calculate the sample variance or sample mean? Yes, but not all the time, because sometimes you can actually input these values into your GC in the table of values, and your table of values from the GC can actually calculate these two data almost immediately. Okay, so as you have seen, the sample mean has this formula, summation of xi over n, alright, represented by x bar, and the sample variance as so. Now we also need to know how this the formula for the sample variance can be reduced, right, from the left hand side to the right hand side. So we need to know how this formula can be reduced to this. Okay, so let's start from the left hand side. So the left hand side, right, so what we can do is we can expand in the quadratic expansion for xi minus x bar. So you will have this, right? Okay, so the next thing is to split the summation, right? You notice that I'm taking out the x bar out of the summation sign because, alright, x bar is just a constant value, alright, but the xi still remains within the summation. Alright, so for the last term, if I were to take out the x bar squared out of the summation sign, so inside within the summation you only have 1. So what it means is, to recap back, your summation, you are basically having when I equals to 1 you have 1, then when I equals to 2 you still have 1, and all the way until when I equals to n you still have 1. So how many 1s you have? So you have n, so you will actually have n here. Alright, so in fact your term, this part here, will be reduced to x bar squared, alright, which is wonderful. Okay, so for the earlier first term here, it will remain the same. Right. In fact, this is a part of the formula that we're trying to show already. Now, you realize that this part here in the second term here, the summation of xi from I equals to 1 to n divided by n, this in fact is your, this part here is your x bar, right? So what you are left with will be, so let me just write this one for you. This should be plus, okay, then in the end you will have 1 over n summation of I equals to 1 to n of xi squared minus 2x bar squared plus x bar squared, right? And this of course can be reduced to the right hand side.